All right, pre-calc honors. Okay, 2 videos. Wow. Man, we haven't had too many videos the entire year, and all of a sudden I'm making 2 for you guys. Must be important, right? Example 4. The equations for free fall near the surfaces of Mars and Jupiter, S in meters, so positions in meters, and T in seconds are Mars, which is the position is 1.86 t squared, with Jupiter's the position is 11.44 t squared. How long would it take a rock falling from rest to reach a velocity of 16.6 meters per second, which is about 16 kilometers per hour on each planet? So we are just going to take one planet at a time. Let's do Mars. And let's do Jupiter over here. Okay, so on Mars, I give you S is 1.86 t squared. It says how long would it take a rock falling from rest to reach a velocity? So I need to find velocity with respect to time, which is S prime of time. So that's going to be 1.86. That's a prime. Leave it out. That's 2t. So V of t is going to give me what? 1.86 times 2, I believe that's going to give me what? 3.72 t. And it said, well, how long is it going to take for it to reach 16.6 meters per second? I'm already in meters per second. Can you see this right here? So I don't have to convert anything. So I'm just going to 16.6. Set it equal to 3.72 t. Divide both sides by 3.72 t. All right, with the help of your calculator, all right, bust out your calculator. Can you tell me, is it exact or is it approximation? All right, you bust it out. You tell me what it is. And let's round it to the nearest 2 decimal places, okay? So about 4.46 seconds, okay? So that's on Mars. Now let's do the same thing for Jupiter. For Jupiter, the equation of position is 11.44 t squared. So velocity with respect to time is just S prime. So that's going to be 11.44 times 2t. So V of t is 11.44 times 2 is 22.88 t. Similarly, we are interested in 16.6 on both planets. So 16.6 equals 22.88 t. Divide both sides by 22.88. Okay, punch it in. T is about, what? Is it now exact or is it still approximation? Did you get the answer? All right, so it's about 0.73, right? And time, so I'm in seconds. So let's write our final answer. It will take about 4.46 seconds on Mars, and much faster, and 0.73 seconds on Jupiter for a rock to reach a velocity of 16.6 meters per second. And I know I might be writing too fast, so just feel free to ask somebody to pause it, or you can pause it, okay? Okay, here we go. Let's do the next question. Find the rate of change of the area of a circle, let's call this A, with respect to its radius. Okay, so let's remind ourselves the area of circle is A equals what? Pi r squared. Nice. Okay, A. Find the rate of change of the area A with respect to radius. Perfect. Rate of change is the derivative. Okay, so we can go A prime with respect to radius is, well, pi is a constant, so you can pull pi out and make it weight. The derivative of r squared is 2r. So A prime r is 2 pi r. Whoa. What is this a formula of? Isn't that a formula of the circumference? Crazy, right? All right. So the rate of change of the area of the circle is the circumference. Oh my. Okay. Evaluate the rate of change of the area at radius 5 and radius 10. We already have the formula, so we just have to plug it in, okay? So A prime r equals 2 pi r. And remember we said if that line means I'm about to evaluate. So I'm just going to plug in 2 pi times 5. That's really 10 pi. Now, you have to give me the unit, the correct unit, okay? So in the velocity, in this case A prime, you always have to give me, we're talking about the area. So it's always the area unit, okay? Which is really, when you talk about area, is unit square, and then versus the radius unit. So let's just say that radius is by like 5 inches. That would be like, area would be like inch square. So inch square over inch. Okay, so this is radius unit. Since it didn't give you anything here, I'm just gonna spell this out for us in that way. All right, so when the radius is 5, the area itself changed 10 pi. Okay. Then let's evaluate it again. What happened when the radius is 10? Is it still 10 pi? Is the rate of change still 10 pi? So 2 pi r, evaluating now at r being 10. So this is 2 pi times 10 equals 20 pi area units. So this is going to be unit square for the area over unit for radius, okay? Okay, so look at that. Even though, so what's going on? The area, the radius is double. The area, is it also doubling? From 10 pi to 20 pi, the rate of change, not the area itself, the rate of change is twice as much, right? So when the radius is increased by 2 times, the rate of change of the area also increased by 2 times. C. Find the average rate of change from radius 5 all the way to radius 10. Okay, so the average rate of change is different. It's not the same. I want you to remember it's not the same as the rate of change. So let me just fix something really quick, make it smaller. Oopsie. Sorry, I need to make it smaller because I can't see any button right now. There you go. Where is this button to make this thing smaller? Come on, dude. I don't want to exit out. I just want my recording screen to be slightly smaller because it's so big right now. It's I can't see the recording button. Sorry, let me find the recording button. Okay, I found it. It's in the very corner and I can't see. Okay. All right. Find the average rate of change of the area from 5 to 10. Now, average rate of change is not the same. I just want to remind you guys, okay, again and again. It's not the same as just average. It's not the same as the rate of change. So average rate of change is pretty much a slope. So I'm going to talk to you about area of 10 minus area of, area, I wrote S. I'm used to thinking about position. Area of 5 all over 10 minus 5. Okay, so area is talking about the normal formula. So the normal formula is pi r squared. So pi 10 squared minus pi times 5 squared over 5. So this is what, 100 pi minus 25 pi all over 5. So this is 75 pi all over 5. So this is, what's 75 divided by 5? Is that 15? Okay, so that's 15 pi area unit square over radius unit. Okay, so look at the difference, right? The rate of change, okay, from 5 to 10 is twice. Would you agree? Okay. But the average rate is 15. So as you can see, that is not always the same, okay? All right, y'all. I'm just going to end right here, and I will see you until next time.